So obviously my presentation is on ballooning. It's balloons are actually what I flew first. So I started flying balloons in 1978, and then I started flying airplanes in 1986, and now, of course, I'm an aspiring glider pilot. So I'll give you tonight a little taste of what flying balloons is like, and then I'm going to go into an interesting flight I made with a good friend of mine, which was a flight we made up to 21,000 feet. And that took some planning and a little bit of effort, and you'll hopefully get an idea for what that was like. So I thought I'd start first that balloons and gliders actually have some shared characteristics. They're both kind of awkward on the ground. Likewise, anybody can glide, but it takes some skill to soar. And the same is true for ballooning. Anybody can float, but it takes some skill to actually fly the balloon to someplace desirable. And the skill set's kind of the same. It takes some effort and some planning and some thought, and not just sitting in the seat and going along for the ride. Both are not terribly suitable for transportation. Probably wouldn't want to use a balloon for transportation, and the same is probably true for a glider. I think also with both of them, there's simply no other way to experience some of what you experience in a glider, and the same is true in a balloon. And it's one of the reasons I've been flying balloons so long, is some of the experiences are really cool, and there's just there's no analog. There's no other way to do that, at least not that I've thought of. And I think the same is true for soaring. What comes to my mind as far as soaring is concerned, and obviously I'm a novice, but the whole experience of ridge soaring is, to me, something really unique, and there's no other way to really do that I can think of. When you're 300 feet above the ridge between Mount Ellen and Mount Abe, and you're cruising along, and there's good lift, and the view is extraordinary. There's really no substitute for that. And that's true for balloons too. So one of the things that's kind of cool about ballooning is mid-air collisions are actually fun and desirable. You couldn't really say that about any other form of aviation. And here we are over Charlotte, just south of where I used to live, and I was out flying with a friend on a nice summer evening, and we just kind of floated into each other, and we kind of hung there for 10 minutes or so of just chatting, and then we sort of moseyed apart, which is kind of cool. And we often joke that, if you filed the NTSB report, you'd say, well, it was actually kind of pleasant, So that's kind of cool. Balloon pilots like water, and because water is kind of fun. And if you're over water, you can actually set the basket down on the water, and it takes a little bit of skill to do it really softly. But if you do, the surface tension of the water will support the balloon nicely, and you'll get maybe an inch or so of water in the bottom of the basket, and the balloon will just sort of float along there. This particular spot is one of the most photogenic spots I know. I used to go to a balloon meet in this little town of Pittsfield, New Hampshire every year. And there's a river that flows through the town, and there's kind of a wide, slow spot in the river, and which is next to the launch field that we use. And often we'd get to just sit on the river in the morning, you get the steam coming off, and it was a pretty idyllic experience. So I don't really know any other way to do that. This was a nice evening over Colchester Pond. So same kind of thing. We kind of dipped down and flew over the pond for a little while, and then climbed back up and flew on to where we ultimately landed. So so it's kind of cool. I don't know of any other aircraft that you could actually go through the McDonald's drive-through, but there you go. It's been done. And there's a whole other segment of ballooning called Cloudhoppers. And Cloudhoppers are small balloons that you just fly in a seat. And so this is my Cloudhopper, and it's about a third the size of a regular balloon. And it's comparatively light. The fabric portion, which is called the envelope, in this balloon, which is actually heavy for a Cloudhopper, weighs about 120 pounds. And a typical sport size envelope weighs about 270 pounds. So this is much lighter, and it folds up small. And I have a Toyota 4Runner. This will fit easily in the 4Runner with all the equipment I need, and still have 3 other seats open. So it's kind of cool. These are pretty neat too, because you can literally fly through the treetops and drag your feet through the treetops. And I don't know any other way to safely do that. And that's kind of a cool experience. And that's a close-up of the bottom end portion of the hopper. You can see the burner, the heater is over my head. And the whole assembly is mounted on a swivel, so you can rotate yourself 360 degrees. It's a pretty cool, nicely engineered thing. And so that's great fun. So now I'm going to talk about this flight that my friend Jeff Snyder and I did. And we had a goal. We started talking about this. We did this flight in 2007, in May of 2007. We started planning it over the winter before. And our goal was, we wanted to get to 25,000 feet. And we didn't make it, we came close, but that was our goal. So we actually got to 21.4. And we burned 60 gallons of propane during that flight, which is a fair amount. We were in the air for 3.5 hours, which is a long flight in a hot air balloon. And we covered 75.5 miles, which is the longest distance flight I've ever had. And so this required some planning, as you might imagine. And the main considerations were airspace, getting the proper permissions, because we're going up into the class Alpha, and we needed the proper equipment in order to make for the conditions of the flight, and also to meet the FAA's requirements. Obviously, weather is always a consideration, so that was something we were careful about. And then, of course, up in the class Alpha, you have to be talking to ATC, and so we dealt with all of these things. The first airspace that we had to deal with was the Burlington, Vermont class Charlie. Anybody who has passed any pilot exam would know that we needed to have two-way communications, radio communications, which simple enough to carry a handheld, and we We brought 2 handhelds and they both failed. So we'll come back to that. But we also, since we're going up into the class alpha, we needed a transponder with mode C, with an encoder. And that's not something commonly carried in a balloon. And so we looked for a battery powered one. And we found one, fortunately, that we could borrow. And so we carried that. Then as far as the class alpha is concerned, that's above 18,000 feet. Up in the class alpha, everything is IFR. So we had that to deal with. Generally, you wouldn't fly a balloon under IFR. Everybody hear me? Oops.
Mind if I?
No.
We heard you before, you just muted yourself again.
I use mine, get that for this one.
Am I audible now?
Yep, you're back up.
Everybody can hear me?
Yes.
Good. Okay, I'll pick it back up. So you need two-way radio communications up in the class alpha. And of course, you need a transponder with mode C up there as well. So we started the whole process of figuring out how to do this. And so the first thing I did was I sent an email to a fellow by the name of John Wood over at the Portland FSDO. And I knew John from balloon safety seminars that I had been going to over the years. And he's a pretty good guy. I think he's since retired, but he was quite helpful. And he referred me to another fellow called Bob Zadzio, who basically said, well, it's kind of the same thing for sailplanes flying wave up into the flight levels, and we don't deal with that. So he basically blew me off. And so then the next thing I did was I knew that I was going to have to deal with Boston Center. And so I started looking for a contact at Boston Center. And I found somebody, and I sent an email request with my proposed launch site and the information about the balloon and an estimate of where we were going to be flying, which of course was just an estimate in the balloon. And he turned out to be very helpful. And so we ended up chatting by phone closer to the flight. And I asked him, did he want me to file an IFR flight plan? And he said yes. And I said, okay, well, I have some questions. The first thing is my true airspeed will be 0. I don't think I can do that. And there was silence. And then I said, I know exactly what my departure location will be, but I really don't know what my destination is going to be. And I really don't know what my route of flight is going to be. And then there was a bit more silence, upon which he said, forget the IFR flight plan. So I said, okay. And he said, here's what we're going to do. He said, when you're ready to do this, call me the night before. He gave me his number. And he said, call me the night before, tell me you're going to do it. And I'll call the folks over at Boston Center, which is in Nashua, New Hampshire, and alert them that you're going to be doing this the next morning. We were planning this for a morning, and then they'll be ready for you. And then he said, just before the flight, call Burlington, tell them you're going to be launching, and then call Burlington Departure as you launch, and they'll hand you off to Boston Center, and then we'll get your clearance. So I said, okay, great. That was great. So that took care of that. So then the next thing we had to deal with which was equipment, and there was a bunch of extra equipment, and I'll go into that. But the first thing was we decided to carry a lot of extra fuel. So normally we would take 2 18-gallon tanks in a balloon of this size, and we took 4. The first one we actually heated, so we had 150 psi of pressure, propane pressure. Propane below about 40 degrees, the vapor pressure of propane falls off precipitously. And so operating normally becomes difficult, if not impossible, because the burners can't make enough heat to fly the balloon properly. So we heated the first tank, so it had quite a bit of pressure. Now, in the research we had done, we were also advised that we should not heat the tanks for flying up high in the flight levels, because we would have too much propane pressure for the amount of oxygen available up there, and the burner wouldn't perform normally. So we were advised to leave 2 tanks cold just the way they were. And then the 4th tank we pressurized, we sort of split the difference and pressurized that kind of midway for the descent and landing. And we figured by the time we were landing, it would be pretty warm because it was May. And so that's what we did. And as an aside, when we decided to do this, over dinner one night, I told Lori, my wife, what we were going to be doing. And she said, I don't want to hear any more about this. And me being a guy and an engineer took that literally. So I didn't say anything more about it afterwards. I subsequently realized that what she really was saying was, don't do this. So the night before the flight, I was busy gathering up all the stuff to do this. And so she saw me running in and out of the garage with fuel tanks and oxygen bottles and radios, and the pile kept getting bigger and bigger and bigger. And finally she said, what are you doing? And I said, well, you told me not to talk to you about this. And she said, well, what are you doing? And I said, well, we're going to make our balloon flight to 25,000 feet tomorrow. And she kind of groaned and then let me go about my business. So anyway, we gathered all our equipment, and so we had extra fuel tanks, oxygen. Normally we would use cannulas, but up above 18,000 feet, we needed masks. So we had masks, plenty of warm clothing, mostly ski clothing, particularly warm boots, 2 radios, which both were troublesome, the transponder and the 12-volt battery for the transponder, which I mentioned, an aviation GPS. We took IFR and VFR charts. We took radios, UHF radios, which we used to communicate with our chase crew, whom we promptly lost and I'll come back to that. Cell phones, which turned out to be useless over the Adirondacks, which is where we went. And then we also took a plumber's torch, thinking that if we had trouble, if the burners should flame out, we reasoned that we would be able to get the plumber's torch lit and use that as a pilot light to relight the burners. So we brought one of those. And then some other miscellaneous things, a first aid kit, some hot tea, water, binoculars, camera, and so forth. And that was pretty much what we needed. And so the next morning, we had been watching the weather, of course. And the first thing was we were looking for a great day, a severe clear day. And we finally had it after waiting weeks to do this. But we were surprised in that that morning, there was a backdoor cold front, which is very unusual, which meant we had winds out of the northeast, which is very rare for around here. We had planned the flight thinking that we would most likely have a northwesterly winds aloft, and we would go fly somewhere toward New Hampshire, maybe even cross into Maine. As it turns out, we ended up flying to the southwest and crossed over the lake. And then we ended up landing down near the Gore Mountain ski area, which is about 75 miles from Burlington. But we had plenty of fuel, and we thought, okay, with more than 4 hours of fuel on board, we have plenty of time to find a launch site, and so we decided to go. So that the evening before, we, as planned, we called Boston Center, and they, true to their word, they said, "Okay, you're good to go. Just call the tower in the morning, and they'll hand you off." And before we launched, we called the Burlington Tower on the phone and told them we were coming. And then after we launched, we called Burlington Departure and checked in, at which point both our radios became troublesome. I, to this day, don't know why. I still use the same handheld that I have literally had since 1986, and it's an ICOM and reliable as can be, but I guess we'll ascribe that to Murphy. But we were able to get enough comm, so Burlington gave us a squawk, and so and then they handed off to Boston, so we could hear them, they couldn't hear us. But they handed us off to Boston, and Boston talked to us, and then finally clearly couldn't hear us. And then what they did was they said, "If you can understand us, squawk ident." So hit the ident button on the transponder, which we did, and so they knew that we were hearing them. And then we had the magic words, cleared up to flight level 250, and so we were on our way. And so we started our climb, and we maintained a climb of 750 feet a minute, all the way up. As I said, the flight path ended up being to the southwest, not the southeast as we had planned. We crossed over the lake at about 18,000 feet going 95 knots. So there was some winds aloft. We could see a long way clear into Maine, looking to the east. And we continued our climb, crossed the lake. Now we were out over the Adirondacks peaks. And then at 21.4, both burners flamed out at exactly the same time, presumably because of oxygen starvation. The balloon actually coasted up a little bit more after that, but we weren't paying attention to where we actually stopped. And then the balloon then, of course, started a descent. And after a couple of minutes, it reached its terminal descent velocity, which is about 1,000 feet a minute. it took us 7 minutes to get the burners relit. So we didn't get the burners relit to 14,000 feet. And we weren't particularly worried about it, but we were surprised at how difficult it was to relight. We first just tried to relight the burners as you normally would and got nothing. And then we tried to light the main flame, not the pilot lights, and got nothing. And then we pulled out our MAP gas torch, and we sat there holding the MAP gas torch. One of us was holding it, the other had a welder sparker to try and light this, and sparks flying everywhere in the stream of gas coming out, and it would not light. And so finally at 14,000 feet, we reverted to trying to light. The burners on these balloons have a metering valve so that you can open the main blast valve and just let it run continuously, but regulate it. And so we opened that slightly, and we were able to get that lit, and then quickly stop the descent. By then, the envelope was very cold, much colder than it would have normally have been, and so it took a little while to heat that up and stop the descent, but we had comfortably leveled out by 7,000 or 8,000 feet. But we're now over the high peaks of the Adirondacks, and we had lost radio contact with our crew. We did at that point manage to talk to the Boston Center controller, who was genuinely excited. He heard from us, and I've never heard a controller get this excited. He said, "That was so cool." He said, "I had a citation go by you at 21,000 feet. He said it was 25 below zero outside." So we thanked him and told him that we were all set, that we would squawk VFR and go about finding a place to land. And so now we're over the Adirondacks. This was ultimately our flight path, and so we launched from near Milton, and then we ended up down here in Minerva, New York, near Gore Mountain. And this was in the climb up toward Lake Champlain. And this is now over the high peaks of the Adirondacks, and you can see there's not a lot out there. This is actually Whiteface up in the clouds, and it was quite spectacular. But at this point, we were certainly thinking about where were we going to land, because that's what it looked like to the west over the Adirondacks. Silas mentioned that he was a little bit uncomfortable about flying here, and as you can see, this is why. So it's very rare that I've flown places anywhere in the United States and see this much of nothing. Roads were typically 15 miles apart here. And that proved to be a problem because mostly we, of course, wanted to land near a road because we knew we were going to have to recover the balloon. But as it turns out, they tend to run power lines along roads, especially out here where there's a lot of nothing. And so every time we came upon a road, there was a power line, and we painfully had to blow off the landing attempt for fear of hitting a power line, which is not something you want to do in a balloon. So we flew on for a while, and then finally we found a small clearing that looked like it was an old building site that nobody had built a home on. There was just a small cabin there. And we were moving along, and we really wanted to make this landing. And so one of the things that you do in a balloon is often, if we're moving faster than we want, we'll intentionally drag the basket through the treetops to slow the balloon down. So that's one technique that you use. And another technique is you can actually bounce the balloon off a tree. And it's just a big inflated ball. And so in this case, we really wanted to make this field, and we actually bounced the balloon off a tree and sort of plopped into this field. Before we had landed, we saw there was a road. We couldn't tell how to get out of this field. It turns out that there was a fire road into this field, but we didn't see that. So we got the balloon deflated and secured, and then kind of bushwhacked out to this road. And then we figured we had hours ago lost our crew. We had no idea where they were. We had established a check-in number that we would both call in the event we got lost. But of course we needed a phone to do it, and our cell phones were worthless. So we just started walking down this road looking for a house. And it was a Sunday morning, and a beautiful May morning. And we're walking down the road, and we see a woman who was gardening out near the end of her driveway by her mailbox. And she looked up at us and saw two guys walking down the road, no car. And she took one look at us and ran down her driveway back to her house. So we walked down the driveway, and at which time her husband came out of the house rather aggressively and said, "What do you want?" And we said, "Well, we landed our balloon across the road in a field over there, and we're looking to use a telephone." And he looked at us like we were insane or escaped convicts, or I'm not completely sure what went through his mind. But I guess eventually he believed us and invited us in, and they were quite kind to us, and of course let us use the phone, which allowed us to make contact with our crew. And then while we were waiting, it took our crew 3 hours to get to us. They had taken the ferry across at Grand Isle, and then made their way down to Minerva. And our saviors gave us breakfast and were very nice to us. And then ultimately, when they got there, the fellow told us where the fire road was into that field, and we were able to drive our truck and trailer right to the balloon, and load it up. And so that's the little field where we landed. This big pine tree is what we bounced off of to get in the field, and we considered it a success. So I figured also as well, I need to include one last photo in the much as John did during his presentation. So you can see that I have indeed been flying balloons for a long time. So anyway, I hope that gives you a little bit of an idea what it's like to fly balloons and what you can do. And if anybody has any questions, I'd be happy to answer them. And if you haven't been in a balloon, I recommend it.
95 knots.
95 knots.
Holy cow.
20,000 feet.
Yeah.
Yeah,
Yeah.
right. 21,000 feet.
Yeah.
It was a cold front.
Yeah.
Going the wrong direction.
Yeah.
I got a question.
Yeah.
How do you bounce a balloon without bouncing the gondola?
Well, the envelope basically is like a big inflated ball, so it'll just bounce off something. And so the guy, the basket will just sort of go with it. It might move around a little bit, but not very much. Yeah. So it's not something that we commonly do, but sometimes you have to be creative. And if we had missed that field, that would have been a problem. We were, at that point, we'd been in the air for 3.5 hours and we needed to be on the ground. So
Fuel getting low.
fuel getting low. Yeah.
So 1,000 feet per minute terminal velocity.
Yep.
Why no parachutes?
Well, there's really no need. I mean, the envelope when it's cold at terminal velocity effectively is a parachute,
But you're gonna hit the ground at 1,000 feet per minute.
which you would do in a parachute anyway, more or less. So you would go bang, obviously. It's not, I wouldn't recommend it. I've never actually done it at that speed. You're not gonna die. You might turn an ankle, you might, and we knew that wasn't gonna happen. I mean, so as part of its certification, every balloon actually is tested to see what its terminal descent rate is. And actually, sometimes you use that because, this whole thing about floating versus flying means that you need to get the balloon to go where you want it to go. And the way you do that, so altitude is your primary control. And then by varying your altitude, you're finding different wind directions. And so sometimes it becomes necessary to do maximum performance operations. And one of those might be put yourself up, at some altitude where you want, and then you know that there's another direction that you want down low, and you need to get there, and you need to get there as fast as you can. So you would drop at the terminal velocity and then level the balloon off, within a fairly narrow band of altitude, such as to get the wind direction that you wanted. And that's entirely normal, on any balloon check ride. An examiner would, you would expect that an examiner would want to see you do that. It's something, it's a tool in your bag that is important, actually, because it is your primary control.
What is the certificated ceiling of that balloon? Or do they have?
No, I don't think, I don't think I don't think it's published. So the limiting factor usually is the envelope temperature, because of course, the higher you go, more or less, the warmer you're going to have to make the envelope in order to keep climbing. And so the fabric has a temperature limit, which is somewhat conservative. On most balloons, most certificated balloons these days, the temperature limit is 250 degrees. And so basically you need a balloon large enough to carry the load you want, so that at something less than 250 degrees, it's displacing enough air to be buoyant with the weight you choose to carry. Because a balloon flies for the same reason a boat floats. You're displacing heavier air than the balloon is occupying, and it floats just like a boat does, because a boat displaces water that's heavier than the space it's occupying.
You have a temperature sensor in the envelope?
So there's a temperature sensor at the top of the envelope that tells you what the temperature is. And generally speaking, you want some margin there, of course. And as well, the warmer you operate a balloon, the shorter its lifespan will be. So, generally speaking, you want, when you choose the size of a balloon, you're doing it with that in mind, of how, I want some excess lift here. So on a warm day, carrying the number of passengers I plan to carry, I'll be able to operate the balloon at, say, maybe 220 degrees, and therefore You have some excess lift, which is a safety consideration. And you also have some excess temperature margin, which makes the fabric last longer. So that's common too.
That's very cool. I really want to ride in one of the ones where you're hanging.
Well, so that hopefully I'll have it together next year. I'm waiting. So the little Cloudhopper that you saw the photo of, I'm getting a 2-place version of that, and I'm waiting for the bottom end componentry to come. There's only one fellow who manufactures a 2-place Cloudhopper with a swivel, and he's quite an engineer. He's a guy called Paolo Bonanno. He's in Italy, and he's designed most of the modern day hot air balloon burners, and he's renowned. And he manufactures these Cloudhopper bottom ends, and he makes single ones, and he makes 2-place ones. And so I have a 2-place one coming, and once I get it, and then the fuel tanks are special, they're purpose built. Once I get all that together, I'll weigh it all, and then I'll calculate what size envelope I'll need for what I want to do with it, and then I'll have that built. And it will be experimental. There's a quirk in the US balloon certification regulations, and no one knows specifically why, but in part 31, which is balloon airworthiness, they specifically disallow a swivel at the interface between the envelope, a balloon envelope, and the gondola. And I don't know why. So Cloudhoppers cannot be type certified. And so they're all built and operate in the US under an experimental airworthiness. In England and in the ESA countries, they commonly do fly those, and they are certified. In fact, England adopted our Part 31 standards and then deleted that limitation on the swivel. So they actually do certify them in England. And most of the Cloudhopper bottom ends are built in England, but this particular one that I'm getting happens to come from Italy. So anyway, when I have it together, I'd be happy to take it. So
I just think it's cool.
it's cool. Like I say, it's there's just no other way I know how to. There is no other way to do that. There's no other way where you can float through the treetops and drag your feet through the tops of a tree safely, and look at that from that perspective. It's a very cool thing. Yeah, or in the hopper, it's funny, if if you're in an area where you're flying over water, you can literally dip your feet in a pond or lake, and that's fun too. It's fun.
I don't know if anybody out in Zoom land has any questions. I can't tell.
I think there were questions in the chat.
I think Jen has a question, but we can't hear her.
I didn't start to say it. I was just waiting to see if anyone else was going to chime in first. But first off, David, thank you. I find this fascinating and really appreciate you putting together this talk. I had no idea, but you were kind enough to let me go up in your balloon when you set it up at the airport a couple years ago. But I like know nothing about it. So this was really interesting. So what is the record for how high a balloon of the type you took up could go, or have not many people done that? What you just did?
Well, so we didn't set a record or even come close to that, and so the record, so the FAI is the record keeper, as it is for really all of aviation, and the records are done by category of balloon, which basically is size. And I think the record for a hot air balloon is somewhere up in the 50,000 foot range, which is really quite extraordinary. So for a size, for for a size reference, so the balloon that you flew in here at the airport, Jen, that balloon is 90,000 cubic feet. The record-setting balloon that was used to go into the 50,000 foot range was 1,000,000 cubic feet.
Wow.
You know, unbelievably massive, heavy thing. So the weight of the air in that balloon that you flew in is about 7,000 pounds, which is significant because you are dealing with that mass, which is why balloons are one of the reasons why balloons are awkward on the ground. In fact, you have to be careful. One of the things we do when we're putting the balloon together and inflating it is we tie it off to something, usually a car or truck. But 7,000 pounds of air is much heavier than most trucks. And so if you're doing this in the morning on a wet, dewy field, and the wind comes up, you can literally drag your truck across the field like it was nothing, because the balloon is actually heavier, substantially heavier than the truck. And so you can imagine what the mass of 1,000,000 cubic foot balloon is. It boggles the mind. These are massive things. So, but then there are altitude records for all size balloons and even little balloons, and the size categories are for hot air balloons. They're AX1 through I don't know, something north of AX10, and then there are gas balloons, so either helium or hydrogen balloons, and those are AA1 through AA. I don't know what the biggest one of those are, and there are different record categories for each of those. Fairly recently, I don't know, maybe in the last 5 years or so, the absolute record for all balloons, which was done in a gas balloon, first was so the original one was set by this I'm having brain fade, I can't think of his name, Joe Kittinger, who was an Air Force pilot in the early 60s. And he went, I think it was to like 103,000 feet and parachuted out of this balloon. And this was research for the space program. And then that record stood till like within the last 10 years when Felix Baumgartner, who's kind of a danger boy, set it after an incredible effort. He was sponsored by Red Bull and had a capsule built. And in fact, Joe Kittinger actually helped him. He was in their mission control. And so he broke the record. Actually, he went supersonic after he jumped out of the capsule and almost killed himself in the process because he was unstable and was spinning out of control. And then about a year after that, a Google software engineer quickly and simply and elegantly broke Baumgartner's record. He had a space suit built for this purpose and didn't use a capsule at all, and just had a gas balloon attached directly to this spacesuit and went up to above 103,000 feet, and then cut away and then parachuted back. And I saw him speak. It was quite funny. They were testing the suit and the parachute out of a cargo plane with a rear ramp that lowers down, and they were trying to figure out how to get him out. And so their solution was they put him on skateboard wheels and just flung him out the back of this thing. the image of that I was kind of funny, but that's what they did, and he easily broke Baumgartner's record very quickly. And so so the absolute record is well above 100,000 feet, which is quite something. Obviously, things are turning dark at that point, and you can definitely see the curvature of the Earth. You're really on the border of space there, very, very close to it. So so people have done that but that obviously is quite exotic.
Wow, that's incredible.
Yeah, no, those balloons, they start out relatively small and slack, and they ultimately explode. They get massive as they expand up at that altitude. These things are giant. 300 feet tall, massive. We're talking hundreds of thousands of cubic feet of gas. It's really quite an orchestration.
So I have a question. So how do you, once you set the basket down and you're landing, how do you get the envelope down on the ground without burning it with the burner or something like that?
So what you do is, so the first thing you do is shut down the burners and then run some raw propane through them to cool them. And then in the top of the balloon, there's a valve. Generally, it's referred to as a parachute valve. And you have a line, and most balloons, and it varies a little bit, but most balloons, so this valve, which may be 20 feet across, is held in place under tension with centering lines. And so by pulling it down, it pulls it away from the seal and it lets hot air bleed. And then when you let it go under tension, it snaps back into place. And so you can use that for maneuvering purposes in flight. So if you want to descend faster than just letting the balloon cool, you would pull on this line, bleed some air out the top, and then let it go, and it would snap shut, and then the balloon would descend faster than it otherwise would. And so for deflation, you basically just hold that valve open and the whole balloon will kind of go over on its side. And you cool the burner so that if it does contact that, you wouldn't melt the fabric. Yeah, so, and it's pretty simple and straightforward. So it takes about typically around a half an hour to assemble and launch a balloon, and about the same to pack it up and put it away. It's fairly typical.
Is there any lateral control at all, like a couple feet? If you could do that air vent off to one side, maybe?
There is not.
Nothing.
Nothing.
Okay.
Now the balloons, the balloon's round, so you can actually spin the balloon. Well, some balloons have vents in them called turning vents. Mostly these are big ride balloons, and so if you pull on a cord, it'll open an opening and bleed air out, and that'll cause the balloon to rotate, but it won't move laterally. It'll just spin on its axis. And yeah, they're perfectly symmetrical, so really they don't move. So it's all about finding a wind that you want. And it's amazing how it depends upon the day, and it'll vary from day to day at what kind of maneuvering you have. And then the orographics of where you are flying are very important. So you can, if there are hills, you can predict what the balloon's going to do because of the orientation of the hill, and you can actually ride some of these air currents around mountains, and it'll actually curve around and so forth. So with a little bit of skill that way, you can actually really maneuver quite significantly. And then there's all kinds of other tricks. One of the things we do is spit over the side of the basket and then watch, and you can see it moving in the air currents as it drops. And it's amazing how you can be 5,000 feet up and see it, like drop several thousand feet and still see it as it's moving around. And that's a very primary indicator that we use. Some people will drop little globs of shaving cream, anything light that would sort of float, and of course you can see that better. But usually there's a fair amount of maneuvering you can do if you're paying attention and working at it. So yeah.
What about mountain wave and balloons?
I think Paul Cram has a question there.
What about mountain wave and balloons? You ever get into
He's unmuted, but we can't hear him.
I think he typed it in the chat box too. ever stumble into the laminar part of mountain wave?
Oh, there we go. No, and you wouldn't want to in a balloon. That would, so of course, your primary control is altitude. And so if you did that, you essentially would lose the only primary control you had. And that's why we fly balloons early in the day or late in the day. Basically, if the conditions are good for soaring, it's lousy for balloons and vice versa. So we avoid thermals like the plague, or any other entity that would affect our altitude. We avoid that like the plague because, like in a thermal, of course, what happens is, say you're in the upward part of the thermal and you're going up, 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 up. Well, what would you do? You'd cool the balloon down to stop that, and finally the balloon would get really cold, and then ultimately you'd get spit out the thermal. Well, now the balloon is really cold, so it's going to start dropping like a stone in the descending air adjacent to the thermal. So now you're heating to stop that, when of course the next thing that happens is you're back in the thermal again. And so ultimately what happens is you have a vertical skid and eventually you'll hit the ground. And so thermals are bad for balloons. They take away really the only direct control that we have.
Great. Well,
Well,
thank
thank you.
David, thank you so much. I loved your talk and loved learning more about the world of ballooning.
Well, thanks. My pleasure.
Well, thank you, everybody. Hopefully, we'll see you next time.
Yeah, I think next week's our last one. And if you guys haven't seen Dave Bonson's talk on his trip to Alaska and his 206 with the motorcycle, it's really cool. But we'll record it like we've done with these others. But I think, yeah, that'll be our last talk. So we've really enjoyed learning more about folks, and thank you for participating.